Hello everyone, this is Chapter 4, Money and Inflation, Lecture 2. And in this lecture, we're going to talk about the quantity theory of money. And we're going to set this up a little bit. Now, I'm going to go pretty quick, and I'm going to give you a very cursory view of the quantity theory of money. Because, well, in intermediate macroeconomics, this is one chapter out of the book. Wherein money and banking, well, it's a really big chunk of that class. So in a little bit different class where we specify or are a little more specifically focused on how the financial sector interacts with the real sector, we'll spend more time on it. So if you're not completely satisfied with everything you learn about the quantity theory and money in general in this chapter, well, take money and banking. So, Lecture 2, the quantity theory of money. The quantity theory of money it's a very simple theory linking the growth rate of the money supply to growth rate of price level. So what we want to do is we want to have a simple way to figure out, well, how do prices evolve over time? Where does this inflation rate come from? And the quantity theory links the growth rate of the money supply, or how much money is in circulation, with this inflation rate. And it begins with a very basic concept called velocity. Now, this is an important concept, so make sure you get this particular concept. All right, velocity is a definition. All right, it's something we're going to define by construction. So the definition, all right, notice it says right here, definition. It's important to remember that. Why does a velocity equal what we're about to say it equals? Well, because we define velocity to do so. Okay, the definition of velocity is the number of times on average a unit of currency changes hands in a given time period. So let's do a brief example. So let's say there's $500 billion in transactions, but the stock of money, the stock of dollar bills, let's say, just to keep it very simple. Now I know the money supply is not all currency. There's other forms of money. But let's, for just a second, suppose that it was just dollar bills. If there was 100 billion of those, how many times on average did each one of those bills change hands? Well, it turns out if there's $100 billion bills and they got spent, and there was a $500 billion in transactions, that means each one of them on average had to get spent 5 times. So they changed hands 5 times, so the velocity is 5. Okay, you can think of it like this. Let's say I have $1. And I go and I buy something from you for $1 and you give that to me. So that dollar got used once. That's 1. And then you go buy something else and you give that to somebody else. It's twice. It's 2. And then it gets used again and used again. Well, how many times on average does $1 get used? That's what velocity is. If you are an accounting major or have taken some accounting classes, you might know the concept of inventory turnover rate. It's kind of similar to that, right? Only it's just how fast do these dollars turn over? How fast do they go from one person to another? And that's why we use the term velocity. And I know all the physics majors in the world out there, you're probably saying, well, goodness, why are you using velocity? That's the wrong term. Isn't it like speed or something like else that you're supposed to be using? You know, I don't know. Leave us alone. We use the term velocity. So if I want to write this down mathematically, velocity is, okay, total expenditure divided by, or total expenditure or the total value of transactions in a given period divided by the money supply. So it's P times Y, or what is this guy? This guy is actually nominal GDP, right? Remember, that's just nominal GDP divided by this money stock. And it's important to note, this M that we're raising here, that's a stock. That's the portfolio of monetary assets. All right, so that's the money stock. Okay, so we have this dealt with on here. Remember, P is the GDP deflator, Y is real GDP. So P times Y is value of output, or better to call it the nominal value of output, all right, or nominal GDP. Okay, so that's the definition. There's something else that's really important to see here, and that is this funky equal sign. No, that's not a typo. That's actually 3 lines. What does that mean? That means this is an identity. What's an identity? It's a definition. So V equals P times Y all over M. Why? Because we defined V to be so. Okay, that's an identity. Okay, so if we rearrange this a little bit, we get a very famous equation known as the equation of exchange. Or if you're from Great Britain, you might call it the Cambridge equation. And actually, there's a little more difference in that. It's actually ultimately the exact same equation. They get to it from you get to the Cambridge equation just a little bit different path than you get to the equation of exchange. But they're equivalent. It's the same thing. We're going to call it the equation of exchange, which is just M times V equals P times Y. Now, before I go on, I want to say that has a pretty cool interpretation. Okay, I know. Cool is relative. You might say, you are many things, Dr. Kelly, but cool is not one of them, and you're probably right. But, all that aside, a really cool interpretation is M times V. Well, what is that? M is the number of dollar bills in circulation. It's not dollar bills, it's the overall money stock. But you can think about it. If there was only currency, that was the only kind of money there was, it'd be the number of the amount of currency in circulation times the average number of times one of those bills gets transferred from one person to another, exchanges hands. Number of times it gets spent. All right, so, well, basically, what is that? That's money spent. M times V is money spent. On the other hand, what does that equal? That equals P times Y. What's P times Y? That's nominal income. That's how much money is received. Oh, I misspelled money. There we go. So what do we have? We have money spent equals money received, which that's kind of cool, right? We don't have any missing dollars anywhere. We don't have any missing money. So we have MV equals PY. That's our equation of exchange. That's not quite the quantity theory, because I want you to note something right here. We could alter this a little bit. We could put a third line in there because that's an identity. The equation of exchange is true by definition. All we did was rearrange the definition of velocity just a little bit. We just moved M from the right-hand side to the left-hand side. That's it. So that's an identity. The equation of exchange is. So that's not quite the quantity theory. So we need to go a little bit farther, and we're going to add a few assumptions on top of that to get to this quantity theory. So in order to move from the equation of exchange to the quantity theory of money, we're going to make 2 fairly basic assumptions. Now, these assumptions are really where we run into a little bit of trouble as to whether or not the quantity theory of money can really explain what's going on with our economy today. But for now, we're just going to propose the theory. And the first assumption is that velocity is fairly constant. That on average, how many times money changes hands in a given period doesn't fluctuate that much. And this is really a very classical assumption. It goes back to the early part of the 20th century. And if you think about the early part of the 20th century, they didn't have as good a data as we have now. And so they had to, on a lot of these things, just kind of make an educated guess. And their guess was, what are some of the key things that would change velocity? Well, one of the big things they thought would change velocity is something called the technology of money. What do I mean by that? Well, the technology of money is, things that affect money. So, for example, debit cards. That was a major innovation in the technology of money that allows me to access the money I have in my checkable deposit, my checking account, much easier. Okay, we could have other things, like, for example, paper money. All right, and in Money and Banking, I talk about the evolution of a monetary system and how on average money comes into existence within an economy. Well, we're not going to get into that here, but the technology of money is just the changing of how we figure out how to transfer money back and forth and use money in different ways. So that could change the velocity. Well, okay. back then, that was pretty constant. They're thinking most of the things that would affect velocity, the other things we're not going to go into there in this class, are fairly constant. So velocity is fairly constant. Assumption number 2 is that aggregate output is at full employment level. So this goes back to Chapter 3. In Chapter 3, we said that, well, essentially, potential GDP, right, the full employment level of aggregate output is fixed. Why? Because technology is fixed, capital is fixed, and labor is fixed. So our inputs are fixed, and our technology is fixed, so potential or long-run aggregate supply or potential GDP is fixed. Great. So that would lead us to believe that V is pretty constant and that Y is pretty constant. Well, I'm going to relax our assumption that we made in Chapter 3 just a little bit. And I'm going to say, rather than just assuming that Y is going to be constant, I'm going to assume that Y grows at a fairly constant rate. Okay, so we're going to ignore, essentially, business cycle fluctuations, recessions, expansions. We're going to ignore those deviations from long-run trend. I know I'm using a lot of terms we haven't talked about yet, mostly because, well, we haven't gotten there yet. And that's why I'm ignoring them. Okay? We have business cycle fluctuations. Those are important, and we'll talk about those, well, in a later chapter. So for right now, we're going to ignore those, and we're just going to assume that, well, velocity is fairly constant and that output grows at a fairly constant rate. So, some implications on this. Number 1, a change in the money supply only changes the price level. Why is that? Because velocity is fairly constant, so money can't change velocity. Output isn't affected by money. Why? Because we said it's either constant or it has a fairly constant growth rate, right? This long-run growth in output is being determined by fundamental factors to the economy, like our technology and our level of inputs. So, money supply changes only affect price level. In other words, money is pretty, what we call, money is neutral. It doesn't affect long-run real GDP. And movements in the price level result solely from changes in the quantity of money. So, fairly strong assumption from these two, well, admittedly, pretty strong assumptions. So the quantity, let's see this a little more clearly by putting the quantity, the equation of exchange, all right, this quantity equation of exchange in growth rate form. And so if we put the equation of exchange into growth rate form, we end up with the growth rate of M plus the growth rate of V equals the growth rate of price level plus the growth rate of output. I can show you that this is approximately true. It's a little bit of an approximation, but the growth rate of a product is approximately equal to the sum of the growth rates. That's just a rule. You can prove it to yourself if you like, but for right now, just trust me. I've put this into growth rate form, and this equation is correct. The next thing I want to do is I want to take a little closer look. What's the growth rate in price level? What's the growth rate in P? Well, that's the inflation rate. Okay, the growth rate of price level, it's just the inflation rate. So let's don't get too complicated or confuse ourselves here. Just the inflation rate. And now we know that, well, wait a minute. Why did I lose the growth rate of velocity? Because I said the growth rate of velocity was fairly constant on the previous slide. Well, I'm sorry, I said velocity was fairly constant on the previous slide. Well, what's the growth rate of a constant variable? 0. Right? If it's not changing, then, well, the change is, well, 0. Okay, so that one goes away, and so we have the growth rate of money supply equals the inflation rate. Notice what I'm going to do is I'm going to take, and I showed you a preview of my results here. I'm going to take this equation and put it right in here, so I know that I can replace that change in P over P with the inflation rate. So I know that what? The inflation rate is approximately equal to the growth rate in money supply minus the growth rate in real GDP. And this is one of the most significant results from the quantity theory of money, is that the inflation rate is roughly equal to the difference between the growth rate of money and the growth rate of real GDP. Okay, so next, let's take some of our assumptions to the data. So what I've done here is I've plotted an estimate of velocity. This is an estimate I have created. It uses both the Monetary Service Index, which is produced by the Federal Reserve Bank of St. Louis, and something called M4, which is produced by the Center for Financial Stability under the direction of Dr. William Barnett. Now, this is an approximation because both of those index numbers that I'm looking at here, M4 and the Monetary Service Index, measure the service flow of money, not the stock of money. And velocity wants the stock. However, there's a pretty direct relationship between the stock and the service flow. And under certain circumstances, I can show that whenever that there's a pretty tight positive correlation between the two. So this is an approximation. It's not exactly correct, but it's a good approximation of the velocity from year to year. And so what I've done here is I've plotted the year-over-year change, so percentage change in velocity. And you'll notice that on average, velocity really never changes year over year by too much more than 1%. And the maximum it's ever changed is here it's dropped by a little more than 3%. And well, here it has almost increased by 3%. So if we look at the maximum amount of change, that percentage change within velocity is somewhere between a maximum of 3% increase or 3% decrease. Okay, well, I guess we could say that's fairly constant. It's not exactly constant, which goes back to our assumption, is the quantity theory perfect for today? Well, not perfect, but it's not the end of the world here. We can also look at our assumption is long-run economic growth fairly constant? Yeah, over the long run, it's fairly constant, somewhere between 2 and 3% for the United States. So that's not a horrible assumption. It's a little dicier when we start factoring in, well, what about business cycle fluctuations? That gets a little more challenging. But for now, this will work for us.